Hello everyone. In this video we're going to continue talking about negative binomial random variable, and here we are looking at the expected value, variance, and standard deviation of negative binomial. And as you can see, all these formulas are functions of r and p. And if you remember, negative binomial is t sub r that has a distribution of a negative binomial with parameters r and p. And what you see here is all these formulas are functions of r and p. And as long as you have those, which are most often given, you can calculate expected values, variance, and standard deviation. So let's take a look at one example here. This one says a city in a coastal area has an erosion prevention program for their beaches. After 3 severe storms, the beaches must be restored with sand from another location. On any given day, there is a 4% chance of a severe storm. We assume that there cannot be more than one severe storm on any given day. The city is interested in studying T3, the number of days until the third storm, the time at which beach restoration must occur. So what we're studying here is T3. Probability of success is 4%. And the first question is, what kind of random variable is T3? Well, here really directly given to us, T3 is a notation for negative binomial. But if that was not the case, you would have to basically just write down T3 is following negative binomial with parameters 3 and 0.04. Now, part B asking us for probability of T3 being equal to 2. Well, we know that the range of T3 really starts at 3. You cannot have 3 storms in 2 days, especially that there cannot be more than one severe storm on any given day. The minimum number of days that we need to have 3 storms is 3. So that's not possible. Essentially, that probability is equal to 0. What is probability of T3 being equal to 3, meaning that it takes 3 days to get to the third storm. So every day we need to have a storm. So we can calculate that probability using the PMF formula that we have, and that would be equal to 2 choose 2 0.04 to 3 times 0.96 to 0. Well, 0.96 to 0 is 1. 2 choose 2 is also 1. So the probability is really 0.04 cubed. What is the probability of T3 being equal to 4? Well, that means it takes 4 days to get to the third storm. And you again can follow the same formula and calculate that. In that case, it would be 3 choose 2 times 0.04 to 3 times 0.96 to 1. And probability of that is 0.000184. Very small. Part E, on average, when will the fourth storm occur? Well, you know that on average means it's asking for expected value of this random variable. What random variable? Fourth storm occur. So that's T4. We're looking for expected value of T4. And that is R over P. Right? So that is 4 divided by 0.04. Well, that means the fourth storm is going to occur on the 100th day, on average. So I want to point out something here. A lot of time in an exam or when you're dealing with a problem that you're not sure it's binomial or negative binomial, you make a mistake, for example here, of taking this random variable as binomial. Here you would have to calculate the expected value. an expected value of binomial, let's say that you made that mistake and take this as binomial, you would have to calculate expected value of n4. An expected value of n4 is np. It will be 4 times 0.04, which is about 0.16. Well, whenever you get to a number, make sure that it makes sense. On average, when will the fourth storm occur? And you're saying 0.16. What does that mean? 0.16 of a day? And that's not possible. So make sure that whenever you're calculating these probabilities and expected values, the numbers, generally speaking, make sense to you. Now, part F, what is the probability that the fourth storm occurs on day 92? The fourth storm is T4, and you want to know what's the probability of T4 being equal to 92, getting to our fourth storm on the 92nd day. And if you do the math here, you would see that that is equal to 0.0085. A little less than 1% chance that you see the fourth storm on the 92nd day. And this probability is very small because what you're looking for is really specific. You want to see the fourth storm occurring on the 92nd day. So that's a really special scenario. And that's why the probability is not that high. It's very small. What is the probability that the fourth storm occur on or before day 5? Well, on or before day 5 means T4 being less than equal to 5. So, probability of T4 less than equal to 5. Well, we know that T4 cannot go below 4. Right? The range of T4 starts at 4. You cannot have 4 storms in 3 days, for example. So that's just a summation of two probabilities. T4 being equal to 5 plus T4 equals 4. We can't go further because there is no probability of T4 equals to 3. It's not possible. So you just need to calculate these two probabilities the same way that we calculated them here using the PMF formula and add them up.